Just have a little more left on this Chapter 5 practice test. Problem 17 isn't much different than a problem that we've done before. Need to get the left side factored, and because I'm having to do grouping factoring, I'm going to do it off to the side just to keep the work a little bit cleaner. You should definitely check the answers. As a matter of fact, if I looked at my answer for 17, I'm shooting for x equal 2/5 and x equal to -1 for my answer. Since it's there, I'm just going to write it down. If I had the answer available to me, I could go backwards and develop my work, but I'll pretend like I don't. I'm going to factor by grouping because of the 5 in front of the x squared, which means I'm going to multiply the 5 and the -2, the outside numbers. I'm looking now for plus minus numbers that multiply to -10. Technically, the bigger number needs to be positive, and they add to +3. And again, technically, that adding is subtracting because the numbers having opposite signs. When you add numbers with opposite signs, you're really subtracting. The numbers I'm going to use are the 5 and the -2, and I'm going to write the -2 first. When I multiply 5 and -2, I get the -10 that I need. When I add them, because they have opposite signs, I subtract and take the sign of the larger. The -2 plus 5 is +3. I'm going to rewrite the 3x, the middle term in the problem, as -2x plus 5x. Always, if I have my choice and there's a positive and a negative, and I'm going to rewrite to factor by grouping, I'm going to put the negative first. It always will make my factoring easier because that will make it so I don't have to factor out a negative. So this is just my side work. Eventually I'll do some work over in this left column to get the answer that I already wrote down. So now that I've rewritten the problem with 4 terms, I break it into 2 halves. Factor out a common factor of an x from the first 2 terms, which will leave me with a 5x minus 2 to put inside a parentheses. The second 2 terms, the 5x minus 2, doesn't have a common factor. Because it doesn't have a common factor, I'm just going to write a 1 and treat a 1 as my common factor. Finish up my factoring. Now I can go back and solve the problem and get the answers that I already know ahead of time. So I've done a lot of side work here to get that left side factored. You don't have to do the work off to the side. I don't always do it off to the side, but when grouping factoring is involved, it makes it hard to follow if you have everything jumbled together. The factoring and the solving of the equation together makes it a little bit, just hard to read sometimes. At this point, now that I have it factored, I can sight solve those without showing any algebra, and I'm good with that. If you want to, the algebra that you'd need to show to get the answer of 2/5 is taking the factor of 5x minus 2, adding 2 to both sides to get 5x equal to 2, and dividing both sides by 5. You could solve this by hand and sight factor that, or you can by hand factor both or sight factor both. It doesn't matter. But I've produced both the answers, and that's all I'm going to do. I'm not going to check, but you should check every time on the test. And I did a lot of checking in the video, so if you're not familiar with how to check, ask me in class, or if we're in an online world, let's do a Zoom meeting and I'll show you how to check again if you don't remember how to do that. 18 is so easy it's hard. 18 actually has the desired setup. The left-hand side is factored, and to the right of an equal sign, there's 0. That's good. You need to keep the factoring when that happens. Earlier, I think it was problem 16, the left-hand side was factored, and I forget what the right-hand side was. I think it was 10. When that happens, you need to get rid of the factoring. So only a few of the problems on this practice test had the left-hand side factored, and only one of them had the left-hand side factored and the right-hand side not zero. Because this is in the position where the right-hand side is zero, I can go straight to getting my answers by just separating each of the factors and setting each one separately equal to zero. The factor of 2x, if I actually set it equal to zero like I want it to solve for x, I would divide both sides by 2 after I set 2x equal to 0. On the left-hand side, the 2's would cancel, and on the right-hand side, any fraction with 0 in the numerator is equal to 0. For the x plus 4 factor, I'll just minus 4 from both sides and get x equal to minus 4. My generic way to write my answer is I write the answer once, the variable once, separate the answers with a comma, and I'm probably not consistent on my order. I just took the order down from how it came. If you wrote -4 first and 0 second, hardly makes a difference. 2 more problems, but they're the word problems. They're not particularly hard, but they're word problems, so I mean they're harder than non-word problems. Problem 19 talks about the width of a rectangular garden being 2 less than its length. And then as I read through problem 19, the second sentence talks about the area of the garden. The garden has an area of 35 square feet. So I know that I'm dealing with a rectangle. And in a rectangle, I generally draw them left and right larger than up and down. And the left and right directions I call L's. The up and down directions I call W's, or widths. So the L is going to be the length of my rectangle, the width is going to be the W, and the very first sentence is going to compare the length and the width, which is important. So the width of a rectangle, the width which is W, of a rectangular garden is, which is equals, and then 2 feet less than its length. This goes all the way back to the first chapter in that chart on the very first section. Less than is a subtraction word, but it's a subtraction word where you switch the order. So the 2 is going to go after the subtraction sign, and the variable that represents the length, which is the L, is going to precede the subtraction sign. So the first sentence gives me the width is 2 less than the length, or the width is the length minus 2. That's the end of the first sentence. The second sentence says the area is 35 feet. Well, I know that A is a good variable to use for area, but it's not a particularly useful variable in our problem. From our problem, instead of writing area, I'm going to write length times width, because the area formula of a rectangle is length times width. So this area equals to 35. I can change to length times width equals 35. And I'm going to substitute that the width is 2 less than the length into the area equation. And this is the equation I'm going to solve. And here, I need to clear the parentheses and get rid of the factoring. If the right side was 0 in this equation, I could keep the factoring. If the left side is factored and the right side is 0, like I did in the last problem, you keep the factoring. The left side is factored and the right side isn't 0, you get rid of the factoring. So I'm going to get rid of the factoring by multiplying L times L to get an L squared. I'm going to multiply L times minus 2 and get a minus 2L. I solve equals to 35. I need to get it set equal to 0. And then I'm going to factor. And in most of the word problems that we did, we got 2 answers. One was positive, one was negative, when they were rectangle problems or triangle problems anyways. And the negative answers aren't feasible. So let me go ahead and factor this. I'm going to cite factor, because there isn't a number in front of the squared term. I don't need to do the side work so much. I'm going to split the L squared evenly into the first positions, and the numbers I'm going to need to fill in after those L's, they need to be plus and minus, they need to multiply to negative 35, and they need to add to negative 2, and that's going to be positive 5 and negative 7, because if you multiply 5 and negative 7, you get negative 35. If you add 5 and negative 7, because they have opposite signs, you'd subtract and take the sign of the larger. That would give me my negative 2. Since I'm not grouping factoring, I don't have to put the negative first. If I was grouping factoring, I'd do negative 7 first, positive 5 second. But for here, since I'm sight factoring, the order really doesn't matter. So I have it factored. Now I'm going to set each of the factors equal to 0. Probably should just sight solve these. The factor of L plus 5 equals to 0 gives me a length of negative 5. This I need to ignore. It's not possible to have a length of a rectangle be negative. Lengths can only be greater than 0. For the L minus 7 factor, I get the answer for the length of positive 7, and the units are in feet. It doesn't look like the word answer, but it's supposed to be. So part of my answer is going to be the length of the garden is 7 feet. And I'm going to get lazy here. I'm running out of room at the bottom of the screen here. And just write words without sentences. I kind of prefer sentences, but I live with this. I need to solve for the width. To finish up my answer, I'm going to use the equation that I created that says width is 2 less than the length, and I'm going to plug in 7 for the length and get 5 for the width. So my width is going to be 5 feet. One last problem to do, another word problem. So at most we're going to get 2 word problems on the test. Sometimes I only put 1 of these word problems. And immediately as I start reading problem 20, it talks about the hypotenuse of a right triangle. Hopefully you remember when I do my triangles, my right triangles, draw them something like this. I make a right angle, or 90-degree angle. The side opposite the 90-degree angle I call the hypotenuse. And then the legs, there's a short leg. I often draw it up and down, but it doesn't really matter. And there's a long leg. I usually make the short leg A and the long leg B. And anytime I'm working with right triangles, I think I'm going to use the Pythagorean Theorem of a squared plus b squared equals c squared. So even without reading the problem, all these things for us, if we're doing a problem about a right triangle, these are all important just knowledge I need to have before I jump into the problem. So immediately, if I read the first sentence, it says the length of the hypotenuse in the right triangle is 5 inches. So that just tells me that C is 5. Done with the first sentence, move on to the second sentence. The longest leg, which is B, which is equal 1 inch longer than the length of the shortest leg. That longer means to add 1 to the shorter leg, and I could do that a couple different ways. So 1 inch longer than the shortest leg A, I can write that as A plus 1 for 1 inch longer than the shortest leg, or I can write it as 1 plus A. This is how it reads to me, but because addition is commutative, it kind of doesn't matter. So the longest leg, B, equals the shortest leg plus 1, or 1 more than the shortest leg. Done with the second sentence, then it says find the length of each side. It must be that A just has to be A. It has no specialness to it. So let me start the Pythagorean theorem then. I'm going to use A squared plus B squared, but instead of B squared, I'm going to write A plus 1, and then squared for the squaring part, equals C squared, which is 5 squared. I'm going to emphasize that this a squared is a 1a squared. It's going to help me in a bit. The a plus 1 squared, I'm going to FOIL by writing it as a plus 1 is times a plus 1, and the 5 squared is 25. So I'm going to get 1a squared plus, and then let me FOIL here. First, our a times a, which is a squared. Outers are a times 1, which is plus 1a. Inners are 1 times a, which is plus 1a. And lasts are 1 times 1, which is plus 1. So the FOILing gives me a squared, which is really another 1a squared, plus 1a plus 1a, which is plus 2a, plus 1. So I've done my FOILing, got rid of all the parentheses, cleaned it up as much as I can, other than combining the 1a squared and 1a squared on the left-hand side. Because there's an equal sign and there's a square, I need to get it set equal to 0. So I'm going to minus 25 from both sides. That's going to give me 2a squared plus 2a minus 24 equals to 0. I'm going to solve by factoring. And the first step in factoring is to pull out the common factor of 2. That gives me 2 times a squared plus a minus 12 equals to 0. I need to sight factor what's inside the parentheses. And when I go to sight factor the inside of the parentheses, I'm looking for plus minus numbers that multiply to negative 12, that add to this implied coefficient of 1. And that's going to be 4 and negative 3, because 4 times negative 3, when you multiply those numbers, you get negative 12. And when you add them, because they have opposite signs, you subtract and take the sign of the larger, so you'll get a 1. So the factoring, the 2 is going to hang out, and I'm going to get an a plus 4 and an a minus 3 on the left-hand side for the complete factoring equal to 0. And then I'm going to set each of the factors equal to 0 and get the numerical answers that they imply. The first factor doesn't have a variable, it doesn't give a solution. Common factors that don't have a variable don't give a solution. The middle one, if I subtract 4 from both sides, gives me a equal to negative 4. And this needs to be ignored because you can't have a negative length of the side of a triangle. And then the a minus 3, when you set it equal to 0, that's going to give me the answer that I need to keep. So that's the short side of my triangle, and the dimensions are in inches. So immediately for my answer, I might say a, comma, maybe the short side of the triangle. I'm not going to write of the triangle. How about equals 3 inches? And then B, which is the long leg. Leg is probably a better word than side because I've been using the word leg, so let me keep that there in that answer, but side is fine. And the long leg, well, how do I get the long leg? B is a plus 1. So because B is a plus 1, and because a is 3, the long leg is going to be 4, and I'll tack on my units. I probably don't really need to give this c because it's not an unknown, it's a given, but I'll give it anyways. The hypotenuse, C, is 5 inches. That's a real classic right triangle, the 3, 4, 5 right triangle. 6, 8, 10 is another classic one. As we did the homework, we probably saw those quite a bit. So that's everything for this chapter between the two parts of the review. Just perfect these 20 problems and you should be good for our test. And then we just have one chapter left, and I think it's a friendly-ish chapter.